Imagine just for a second that you are a CEO. It's the year 2030, and your enterprise AI system has just made a really high-stakes, highly controversial decision.
Right, like denying a massive commercial loan or automatically terminating a critical supplier contract.
Exactly, based purely on some internal risk assessment. And now the regulator is sitting across from you right there in the boardroom. And they are asking for, a glossy summary of your AI policy.
No, they want the math.
Right. They are looking you in the eye and asking a incredibly precise question, something like, can you prove exactly why this specific decision was made, who authorized it, and what data it pulled from at that exact millisecond?
And honestly, for most executives today, that is the exact moment the temperature in the room just drops.
Oh, absolutely.
Because the honest answer is almost always a guess. I mean, they might point to a vendor's compliance dashboard or pull up some general architecture diagram, but they simply don't have undeniable reconstructed proof of that single transaction.
Which is a terrifying position for any enterprise leader to be in. You either have the math to back it up, or you are facing a massive, potentially existential fine.
Yeah, the liability is just immense.
And that unyielding reality is exactly why we are opening up a very premium boardroom-grade operating manual today. We're doing a deep dive into the AI Skills Cookbook for the CEO of 2030.
It's a fascinating document.
It really is. And specifically, we are unpacking Course 2 of this manual, which is titled Less Sauces.
Right, which is a very deliberate kind of culinary framing.
Yeah, explain that a bit.
Well, if you think, of course, of this cookbook as being about building the physical kitchen, so buying the servers, licensing the large language models, setting up your cloud infrastructure, then Course 2 is about the sauces.
The governance primitive.
Exactly. The sauce is the invisible binding agent that dictates how the operation actually runs day to day. You could easily have two Fortune 500 companies using the exact same underlying AI models, but their governance sauces will make their risk profiles look entirely different to an auditor.
And to solve these cutting-edge, 2030 boardroom problems of AI auditability, this manual does something really interesting. It completely ignores Silicon Valley.
It does. It completely bypasses modern tech culture.
Right. The cultural anchor for this deep dive is actually India. The core doctrine here is that governance is fundamentally flavor management. To solve high-stakes AI liability, the text argues we have to look at centuries-old Indian institutions.
From Mughal courts to Ayurvedic apothecaries.
Because long before the first line of code was ever written, these institutions mastered the art of high-stakes, zero-trust governance.
Yeah, because true governance isn't some modern invention born out of a tech compliance department in California. It is a very ancient discipline of managing authority, memory, and ingredients.
Which brings us to the first requirement. Before any AI system can execute a decision, it needs two things just to wake up.
Ingredients and a trigger.
Right. Data and a signal. Let's start with the ingredients. I mean, in a lot of modern enterprises, data lakes are basically just massive dumping grounds. You pull in everything and sort of let the AI sort it out later.
Which the cookbook argues is a completely toxic approach. It introduces this as Recipe 13, the Dataset Governance Pack, and it uses this brilliant metaphor of the Vaidya's cabinet.
From the Ayurvedic tradition in Kerala, right?
Exactly. A Vaidya is a traditional physician, and they rely on this heavy teak cabinet filled with hundreds of medicinal herbs. But the absolute non-negotiable rule of the practice is that every single jar in that cabinet must carry a precise, unalterable label.
Not just what the herb is, but the context around it.
Right. The label details the plant's exact origin, the specific season it was harvested, the processing method, and most critically, its contraindications.
Meaning the specific conditions under which this herb becomes toxic to a patient.
Precisely. And if a jar loses its label for whatever reason,
The physician throws it out.
they have to. You cannot guess. An unlabeled jar is a lethal liability in medicine. And in the AI enterprise, an unlabeled dataset is that exact same unlabeled jar. It poisons the entire model.
So if you are pointing an AI at a dataset to make, say, a financial decision, the book says every single table needs a provenance card.
Yes. You must track its origin, the lineage of how the data was transformed, any external sub-processors that touched it, and of course those contraindications.
So a contraindication in an enterprise setting would be something like, this data was collected exclusively for customer service routing. It must never be ingested by the credit scoring algorithm.
Exactly. You are attaching a strict legal passport to the data itself. But, having label ingredients is only the first step. The system also needs to know why it's authorized to start cooking in the first place.
Which brings us to recipe 14, the triggering condition. And the manual compares this to the bell at the threshold in a Tamil temple.
Yeah, the Tamil Temple Gopuram, the monumental entrance tower.
I found this connection just fascinating.
It really is, because in this tradition, ringing the heavy brass bell at the threshold isn't just a nice ceremonial sound. The winging of the bell is the unofficial audit record of entry. The deity is notified, the priests are aware. The physical act of entering and the official record of entering are the exact same physical motion.
No worship and no action begins without that specific threshold event.
Right.
So if I'm applying this temple bell concept to a modern cloud database, I imagine that translates to a mandatory field. Like the AI literally cannot execute a command unless the trigger cell is filled out. Is it a hard block in the system?
It is an absolute uncompromising hard block. It is a mandatory field, literally called triggering condition. Before your AI takes any consequential action, say freezing a user's bank account, you must record the exact threshold that was crossed to wake the AI up.
Give me an example of what that looks like in the code.
Well, did a fraud detection score drop below 90%? Did an API receive a specific flagged payload from a third-party vendor? You must record the mathematical why before the action proceeds.
I hear this, and, a part of me immediately thinks about the engineering teams who actually have to build and maintain this. If I'm a product manager, forcing the system to meticulously record the origin of every single data point and the exact trigger of every single action, it sounds like forcing a chef to write a detailed essay about an onion before they're allowed to chop it.
It does sound like that, yeah.
Are we just smothering commercial speed with endless digital paperwork?
That is always the very first pushback from engineering. But it fundamentally misunderstands the mechanism. This is not retroactive paperwork. You aren't asking a developer to fill out a compliance form in triplicate at the end of the month.
Right.
This is executable infrastructure.
Meaning the database itself enforces the rule at the very point of compute.
Exactly. The system is hard-coded to refuse the compute cycle entirely unless the provenance card is scanned and the trigger is mathematically logged. It all happens in milliseconds. It's really about structural balance.
You're protecting the enterprise from catastrophic legal liability by building the governance into the actual physics of the architecture.
Rather than relying on human memory in a committee meeting 3 weeks after the fact, yes.
All right, so the system is locked, the ingredients are perfectly labeled, and the trigger's pulled. The AI executes the compute. But, and this is a big compute, but an AI doesn't have a moral compass, and AI certainly can't go to jail.
No, it cannot.
So if it makes a disastrous decision, who is the human actually on the hook?
This is where we get into the architecture of human oversight. We have to transition from just preparing the ingredients to establishing the human authority required to actually serve the dish to the public.
And the cookbook addresses this with Recipe 11, high-risk decision memos.
Drawing heavily on the Council of Ministers in the Mughal Diwani cause.
The Hall of Private Audience, right?
Yes. In the Mughal court, high-stakes decisions of state were never, ever taken in secret corridors or just inferred from casual conversations. They were taken visibly in a recorded chamber and signed by a named human authority before the action was executed.
And for enterprise AI, the manual insists that post hoc memos written after the AI has already acted, are legally worthless.
They are just stories you tell after the fact to make yourself feel better. If your AI is configured to make a high-risk decision, a named human principal must cryptographically sign off on the parameter change before the system ever goes live.
Which naturally sets up the physical gatekeeping of the outputs themselves. Recipe 15 is the HITL gate, human in the loop.
And the anchor here is wonderful, the royal tasting from the imperial kitchens of Shahjahanabad.
The emperor never ate untested food.
Never. A dish had to pass through a very rigid hierarchy of named tasters before it ever reached the throne. And this maps perfectly to the modern 4-tier HITL standard for enterprise AI.
Which are always exception, async, and no HITL.
Right. The architecture must physically refuse delivery of the AI's output to the end user if the designated human taster hasn't literally signed off on it.
Let's talk about the practical scale of that, though. Because if I'm running a massive automated loan processing system, I am generating tens of thousands of decisions an hour.
Easily, yeah.
If I need a human to, quote-unquote, taste every single output, I have to hire an absolute army of reviewers. My margins evaporate overnight.
And that is exactly why the manual pairs the HITL gate with the authority matrix. You do not taste everything equally. That would be absurd.
So how does the matrix work?
The matrix automatically maps the risk tier of the action to the required tasting tier. Over-tasting routine, low-stakes actions is a massive cost overhead, but under-tasting high-risk actions, that is a terminal liability.
Okay, so a routine password reset triggered by a user would hit the matrix and be routed as NOHITL. It just happens instantly.
Exactly. Or, like, a standard product refund under $50 might be ASYNC. The refund processes instantly for the sake of customer satisfaction, but a human reviews a batched sample of them the next day just to check for anomalies.
But a decision to deny a commercial mortgage.
That hits the matrix and is immediately flagged as always. The system physically holds the email. It will not send the rejection until a human underwriter reviews the AI's logic and applies their signature. You get speed where it's safe and friction where it's legally necessary.
That makes sense. But that brings up the human element of the reviewers themselves. We've all seen this in corporate IT. You get a pop-up on your screen, you're busy, you're tired, and you just blindly click approve without actually reading the details.
Rubber stamping. It's incredibly dangerous.
Right. And the manual attacks this rubber stamping problem in recipe 16, the reviewer's console. And it uses the analogy of the guru's mirror.
This is a beautiful concept. In the Carnatic music tradition of southern India, the guru, the master teacher, does not just sit anywhere in the room. The guru's chair is placed at a very precise, calculated angle to the student, often utilizing a strategically placed mirror.
And what's the purpose of that?
The entire purpose of this geometry is so the guru can see the physical mechanics of the student's performance, the posture, the diaphragm breathing that the student cannot possibly see in themselves.
The placement is engineered specifically to reveal blind spots.
Yes. Applied to your enterprise, your human reviewer's console must be engineered the exact same way. If your AI suggests denying that commercial mortgage, the console cannot just present a big, friendly, green, approve AI decision button.
It has to force the human to look in the mirror.
It has to display the AI's confidence score, the specific data weights that drove the rejection, and the alternative scenarios. A human rubber stamping an AI's output without being forced to interrogate the underlying logic is honestly worse than having no reviewer at all.
Because it gives the board the illusion of safety, while the human just assumes 100% of the liability for a machine's hallucination.
And exactly. You are just inheriting the AI's mistakes with your signature.
All right, let's fast forward the timeline a bit here. The system was locked, the trigger fired, the matrix routed it to a human, the human looked in the guru's mirror and approved it. The decision goes out into the real world. 6 months later, the regulator knocks on the door and audits that specific decision.
Right. The moment of truth.
How do we guarantee we can prove what happened 6 months ago?
Well, we have to shift from executing the action to permanently preserving the action. We literally have to freeze time. This is recipe 17, the system state snapshot. And the manual takes us to the Akhada, the traditional Benares wrestling gym.
Where before a wrestler ever steps into the dirt ring for a bout, they are meticulously measured.
Their weight, their diet, their physical state is recorded to the ounce. They capture a snapshot of the wrestler's exact state at that exact moment in time.
In an enterprise AI, this translates to the system state snapshot field.
Right, because AI is not static code. It is a probabilistic model. Models experience drift over time. Your cloud vendor might silently update the underlying language model over the weekend without telling you.
Right, the AI you were using to make decisions in December is mathematically not the same AI you were using in June.
Which means if you don't capture the exact state at the moment of the decision, the context is gone forever. Right before your AI takes a consequential action, the system must automatically capture a version-controlled technical record.
Like, what was the exact prompt string used?
What were the specific model weights? What was the temperature setting? You capture the snapshot of the digital wrestler.
And here's the IT reality. A snapshot is completely useless if someone with admin rights can just log into the database 3 months later and quietly alter it.
Which introduces recipe 18, the append-only audit log, inspired by the stone tablet.
Specifically, the edicts of Emperor Ashoka.
Yes, carved into massive granite rock faces at Girnar 23 centuries ago. Ashoka didn't write his laws on palm leaves that could be burned or rewritten. He chose granite specifically so they could not be edited by future regimes or, altered by corrupt regional officials trying to bend the rules.
And for your enterprise, your AI audit logs must be digital granite. They must be strictly append-only, locked down at the database level.
Usually using tools like JSON-B columns and cryptographic hash chains.
Right, a JSON-B column is essentially a flexible vault within a single database row that can perfectly store the really complex nested data of your AI snapshot.
And the cryptographic hash chain ensures that every new entry is mathematically locked to the one before it.
But look, theory is great, but in a live enterprise environment, databases get messy. Let's say a corrupted API misfires over the weekend and writes 50,000 absolute garbage lines into the audit log.
It happens all the time.
And it's crashing the visualization dashboard. My engineering team needs to go in and delete those rows just to keep the servers from falling over. If this log is absolute, uneditable granite, my engineers are stuck. Absolute immutability sounds like a fast track to a massive system outage.
It is an absolute headache for IT, I won't deny that. But the mechanism to handle that isn't editing, it's appending.
What do you mean?
If row 100 is corrupted garbage, you do not grant an admin the power to delete row 100. You write row 101, which officially stays. Ignore row 100 due to API error. The error remains in the granite.
Wrong.
And the manual delivers a core, uncompromising doctrine on this. It says an audit log that can be edited is a diary, not a record.
A diary, not a record. That leaves zero wiggle room.
Think about the psychology of the regulator sitting across from you. If a database administrator has the access privileges to go back in time and update a row to, quote-unquote, fix a typo, the regulator is forced to assume that someone also has the privileges to update a row to hide a crime.
That's a chilling thought.
You cannot sit in a boardroom and tell an auditor, well, we promise our IT team only uses their edit rights for good. You have to strip away your own power to edit. You carve the medium so that retroactive manipulation is mathematically impossible.
Okay, so we have an uneditable log carved in digital granite. We know the snapshot, the trigger, and the human sign-off. But just looking at a row in a database isn't the same as proving the logic actually works the way you claim it does.
No, it's not. Which brings us to the ultimate standard of defensibility, the final flex in the boardroom. You don't just hand the regulator a printout. You take that log and you actually rerun the past to prove it is mathematically true.
Recipe 19, the replay verifier. And the cultural anchors here are brilliant. We have the Mumbai Dabbawalas and the Masala Dabba tasting spoon.
Let's break down the Dabbawalas first. They operate a lunchbox delivery system of staggering complexity in Mumbai. They move millions of hot tiffins daily across a chaotic transit network with Six Sigma reliability.
And they don't do it with modern cloud routing software.
Not at all. They do it with simple, highly specific alphanumeric codes painted right on the lids of the tiffins. That code contains the origin, the exact train station routing, and the final destination. By just looking at the lid, the entire journey is perfectly reconstructible.
So how does a painted routing code translate to testing an enterprise AI?
In software, that routing code is your version control tag. To prove your AI's decision to the regulator, you have to use that tag to route back to what the book calls an isolated namespace.
And what exactly is an isolated namespace in this context?
It is a quarantined digital sandbox. You completely sever the AI from the live internet of today. You force it to run inside an environment that exactly mimics the server state from 6 months ago.
Okay, and once we route it into that isolated environment, we use the Masala Dabba.
Yes. The Masala Dabba is the traditional Indian spice box. The tasting spoon protocol dictates that before a major dish is served, you replay the flavor profile on a spoon against the master recipe to ensure absolute consistency.
So for your AI, this is the reconstruction principle.
Exactly. You take the frozen system snapshot, you inject the exact triggering data from the uneditable log, you hit run in the sandbox, and you just watch the AI process the data all over again.
You are literally time traveling, rebuilding the exact room, dropping the exact data in, and watching the machine think.
And the verifier script must return one specific output, parity. True. You must get the exact same mortgage denial today that you got 6 months ago.
And if it returns false,
if the AI makes a slightly different choice on replay, your entire governance framework collapses. It means there was a hidden variable, some shadow context pulling strings in the background that you failed to log.
Which brings us to the grand finale, the actual physical package you hand to the regulator to prove all of this. Recipe 20, the evidence package, modeled after the Vedic Panchami.
The Panchama is a sacred offering plate consisting of exactly 5 elements: milk, curd, ghee, honey, and sugar. It is never 4 elements, it is never 6. All 5 must be present, and they are offered together as a single, unified whole.
And the enterprise AI equivalent is the 5-tuple.
Yes, the 5-tuple evidence package. First, who was the authorizing human principal? Second, what was the exact payload or action taken?
Third, when did it happen? Logged with a synchronized, unalterable timestamp.
Fourth, why did it happen? The triggering condition. And finally, the fifth element, the proof.
Let's focus on that fifth element for a second, the proof. That's the cryptographic hash we touched on earlier. Think of a cryptographic hash like a hypersensitive digital fingerprint. It takes the who, what, when, and why and mashes them through a complex algorithm like SHA-256 to create a completely unique string of characters.
Exactly right. In the Panchimit ritual, a diya, a small traditional oil lamp, is placed at the very center of the offering plate. That cryptographic hash is your digital diya. It acts as a seal across the other four elements.
So if a bad actor goes into the log and tries to alter just a single comma in the Y data, maybe they're trying to change the triggering condition to hide a costly mistake, the digital fingerprint of the data completely changes.
The hash breaks.
Right, and the tampering is instantly obvious.
The math instantly exposes the lie. All five elements are structurally bound together by that hash.
But let's say I'm in that 2030 boardroom. I have 4 out of the 5 witnesses. I can confidently show the regulator the who, the what, the when, and the why. But during a messy server migration last quarter, the cryptographic proof the hash itself got corrupted or lost.
It happens.
Practically speaking, isn't 4 out of 5 a solid passing grade? Can't I just reasonably explain the logic of the decision to the auditor?
In a casual conversation with your board of directors, sure, yes, you can explain it. But in a hostile regulatory audit, absolutely not. The cookbook is ruthless on this specific point. It says 4 witnesses is a story, 5 witnesses is evidence.
That is a brutal standard to meet.
It has to be brutal because the scale of AI action is brutal. Anything less than the complete 5-tuple sealed together with an unbroken cryptographic hash means you cannot mathematically defend the system.
You are just telling the regulator a nice logical story about what you think your AI did.
And in 2030, regulators will not issue conformity certificates based on nice stories.
Looking at this entire framework, from the rigorous labeling of the Vidyas cabinet to prevent data poisoning, to the hard blocking trigger of the temple bell, the visual accountability of the guru's mirror, all the way to carving our snapshot into the digital granite of the Ashoka edicts. A very clear theme emerges here.
It does.
You tend to assume that enterprise AI compliance is some brand new, sterile puzzle invented by modern tech lawyers, but it's really not.
Not at all. The underlying technology is novel, obviously, but the human problems of authority, verification, and institutional memory are ancient. We are just applying the centuries-old discipline of flavor management to silicon and code.
You don't need to invent new philosophies of accountability.
No, you just need to wire the ancient ones directly into your architecture.
And that is the ultimate takeaway from Course 2. The tools have changed. We use isolated namespaces and SHA-256 hashes instead of teak cabinets and tasting spoons. But the fundamental recipe for trust remains exactly the same.
It really does.
Which brings us to the closing doctrine of the cookbook. It's something for every executive listening to mull over. Intelligence is the ingredient. Governance is the recipe. Trust is the meal. You will, eventually, eat what you sow.
So you really need to take a hard look at the architecture you are approving today.
Imagine yourself back in that boardroom in 2030. The AI has acted. The regulator is sitting across from you asking for the official record. Are you going to hand them a diary full of editable stories and broken hashes? Or are you going to serve them a 5-witness plate of undeniable mathematically sealed evidence? The choice of what you serve tomorrow depends entirely on the kitchen you build today.